Entropy is a measure of the energy dispersal in the system. We see evidence that the universe tends toward the highest entropy many places in our life. A campfire is an example of the entropy. The solid wood burns and becomes ash, smoke, and gases, all of which spread energy outwards more easily than a solid fuel. Some examples of entropy are melting ice, sugar dissolving, boiling water, and also the most important one, making popcorn.
Entropy and the laws of thermodynamics. The first law of thermodynamics is concerned with the energy used in the processes. It does not talk about the conservation of energy or the flow of heat from a cool body to a hot body. But that, there is second law of thermodynamics. The second law of thermodynamics states that the entropy, which is a measure of the system's thermal energy per unit of available temperature for doing useful work, of an isolated system increases in a natural thermodynamic process. It also makes believe the fact that the heat cannot be transferred from a body of low temperature to that of a body of high temperature without adding energy to it.
When a bag of popcorn is heated in a microwave oven, the corn kernels explode into fluffy edible structures that are just the right snack for a football game. If, however, you then decided to remove thermal energy from the popped kernels by sticking them in a refrigerator, they will never change back to their original unpropped state. Why can't the process that occurred in the oven be reversed, like a videotape run backwards?
Time has direction. The direction in which we age, we are accustomed to one-way processes, that is, processes that can only occur in a certain sequence, the right way, and never in the reverse sequence, the wrong way. An egg is dropped onto a floor, a pizza is baked, a car is driven into a lamppost, large wave erode a sandy beach. These one-way processes are irreversible, meaning that they cannot be reversed by the means of only small changes in the environment.
However, there are also a few examples of reversible changes, such as first, the melting of ice, second, the blowing of the balloon, third, writing with pencil on paper and rubbing with eraser, and fourth, stretching rubber of spring.
Are the drinks about our entropy, correct? Yes.
Once a crystal salt is dissolved in water, the positively charged sodium ions and the negatively charged chloride ions are associated with the oppositely charged polar end of many water molecules.
Oh my god!
Air is pumped into a tyre. For the same reason as the second one, this is a negative entropy change because you're restricting air molecules into a smaller space. A car tyre is pumped to high pressure and punctured. The air rushes out. The relatively large energy of the pressurized air in the tyre disperses when the tyre is punctured.
Everything in the world is made up of particles that act differently depending on the state they are in. An ice cube is made of water particles, but it is a solid because its particles are packed closely together, resulting in this hard, fixed state. When a solid ice cube is removed from a freezer, the warmer air gives its particles the heat energy they need to split apart. When you take ice cubes out of the freezer, the melting process begins right away because the air temperature around the ice cubes is warmer than the temperature in the freezer.
When the water is boiled, the level of disorder increases. This is because the water is changing state from liquid to gas. Thus, entropy increases.
To summarize this video, entropy ensures randomness and spontaneity. Like the internal energy, entropy is a state function. Entropy depends on the transfer of heat and the temperature of the system. By the way, thanks for watching.